Well, this video is for the assignment on percent applications for Math 60. And so just a quick review, when we were doing those percent calculations in the last assignment, there were essentially three ways to go about doing this, or three things that we were looking for. There were two different ways to go about it. So we had is over of equals percent over 100, or we had the percent as a decimal multiplied by of equals is. So there's two different ways to do it. In each method, there are three things that we're looking for, or three possible things, that one of three things we're looking for, is, of, or the percentage. Okay? So, in doing these word problems, it's really important, whichever method you're using, to decide which of these three things are we looking for. And then that'll lead you to the solution. Okay? So, for example, again, I'll do the even problems on this assignment as examples. So, problem 2 says a house has 1,200 square feet on the first floor and 800 square feet on the second floor. So let's see, I'll go ahead and write this down. First floor, 1,200 square feet. Second floor, 800 square feet. What percentage of the square footage of the house is on the first floor? Okay. So, the question is, are we looking for is, are we looking for of, are we looking for the percent? Well, notice that there's no percentage in the problem. That's usually an indication that we're looking for the percent. Okay? So, that's going to be our x. And over here, once we get away from those simple calculation problems to the word problems, notice that the words is and of often are not in the problem. Okay? Although in this one, let's see, what percent of the square footage of the house is on the first floor. So they are actually in the problem, and they are not really misleading. Okay? Is the first floor. Okay, that's 1,200. Of is the whole house. Okay, so notice that the whole house is not the 800, this is 2,000 square feet, right? Because it's 1,200 on the first floor, 800 on the second floor, 2,000 altogether. All right, so to solve this, we can cross multiply, so 2,000x equals 1,200 times 100, and then we do, what is this, 120,000 divided by 2,000. That should be 60. Yeah, 60%. 60%. Okay, and also, like I said, in this problem, we happen to have the is and the of language in the problem. That's frequently not the case, and it's helpful to think of this as part and whole, as long as you understand the part can be bigger than the whole if the percentage is over 100. Okay? All right. Well, that's a good place to start. Let's see, I'll leave that up there, and then we'll take a look at problem 4. Okay, these next three problems, 4, 6, and 8, are all discount problems. So let's take a look at these. Problem 4. An item originally cost $180, and it's being discounted by 15%. Oh, 15%. And the question asks, find the amount of discount and the new price. Okay. So, a discount is a percentage of the normal price. Okay? So the idea is you apply the percentage to the original price and then subtract that much away from the original price. So the amount of the discount is going to be 15% of $180. Okay, and so if you were to set this up, you could do it like that. You could also do it like this. So let's see here, what would we get? $27. Okay. So that would be $27. And so that's the amount of the discount. So let's see here. Find the amount of the discount and the new price. So the amount of the discount is $27, and then the new price would be 180 minus 27, so that should be $153. Okay, so there's problem 4. So that was an is problem. Okay. Now, problem 6 says the item is on sale for $105. So we've got this sale price equal to $105 after being discounted by 30%. What was the original price? Now this one is a little bit tricky, okay? And we'll see another one like it in just a minute. Problem 8 is very much like this. So notice what happened here. The sale price is related to the original price and the discount, okay? Notice that it was the original price minus the amount of the discount to give you the sale price. Now we don't have any of that information. We don't have the original price, we don't have the amount of the discount, but we do have the percentage of the discount. And in the same way that you do 180 minus 27 to give you the new price of 153, with the discounts you would take 100% minus 15%. This is now 85% of the original price. Okay? And you can try it out if you'd like. You can take 180 times 0.85, and that'll give you $153. So what we're saying here is that our original price the original price, well, the sale price is 70% of the original price. So if we take the original price and multiply it by 0.7, that should give us $105. Okay? So if we were to set it up like this, there's our percentage here. The of is what we're looking for, and the is the sale price of $105. And you can do the same thing over here. You put the 70% in here, the 105 in here, and the X down there. But the key to doing these discount problems when you know the sale price and the amount of the discount is you have to subtract from 100. Okay? And so now, let's see here. If we do 105 divided by 0.7, that tells us the original price then is going to be $150. Okay? So I found that by setting this one up like that and dividing on both sides by 0.70. Okay? You can also do this. You can say 70x equals 105 times 100, and then you do 10,500 divided by 70, and you still get $150. Okay, so there's problem 6. Let's look at problem 8 because it's very similar. It's the same problem, just with different numbers. All right, problem 8. An item is on sale for $675, so we've got the sale price, $675. $675, and we know the discount in problem 8 was 10%. Okay, so that means that this sale price is going to be 90% of the original price. Okay, and so now we're going to set it up the same way that we did over here. We can say 0.90 times x equals 675, or we can say 675 over x equals 90 over 100. Alrighty, let's see, 675 divided by 0.9, x is $750. Well, we can get the same thing here. 90x equals 675 times 100. Divide on both sides by 90. And x is $750. Okay, so there's the discount type of problem. Okay, well, let's keep going here. So again, the main issue in doing these problems is deciding which type of problem is it. Are you looking for is, of, or the percent? Okay. So that's the first thing you really want to figure out. Problem 10, in a survey of 1,250 Americans, 461 rated their health as excellent. What percentage of those surveyed rated their health excellent? So now we're looking for the percentage. Okay, so that's going to be our x. The is the part, the of is the whole. So the part is the 461 people that said they were in excellent health, and the whole is the total number of people who were interviewed. Okay, let's see. So if we set this up, we can do 1250x is 461 times 100. And that comes out to 36.88. And there we go. It's a terminating decimal. There's really no reason to round it off. Okay? If you get something that keeps going and doesn't repeat, then by all means go ahead and round it off. But if it's a terminating decimal that only has 2 or 3 places in it, or if it's a repeating decimal, then you should either indicate it's a repeating decimal or include all of the digits after the decimal point. Unless the problem asks you to round it off. And there are a couple in here that ask you to round to the nearest 1/10 of a percent or so. All right, let's see here. Problem 12. A sales rep is paid 5% commission on their monthly sales. If they received a commission of $700, what were their total sales for the month? All right. So this one, it's not as obvious immediately what we're looking for. Okay. If you recognize right away what we're looking for, great. Okay. In this case, it turns out we're looking for of. Okay. We're looking for the total sales because this number 700 is 5% of those sales. So this is the is, this is the percent, and we're looking to find the of. Okay? And you can also say 0.05x would be equal to 700. Yeah, I think instead of I'll put an x in there. There we go. So then 5x would be 700 times 100. And so that gives us x is 14,000. Okay, so on total sales of 14,000, the sales rep gets a commission of $700, which is 5% of the total sales. And it's a good idea to check yourself and make sure that things make sense. If this percentage is less than 100, then your is should be less than your of. If this is bigger than 100%, then this will be bigger than the of. All right, let's see here. Problem 14. There were 10,850 votes cast, so this is total votes, and that's a good sign that this is the whole, okay, or the of piece. And that's 10,850. And then the winner received 62% of those votes, okay? So, we are looking for the part. We're looking for how many votes is 62% of 10,850. And you can do this a couple different ways. You put your x over 10,850 equals 62 over 100. Or you can just go 0.62 times 10,850. Let's see what we get here. And that's 6,727. Here you would get 100x is 10,850 times 62. So let's see. That would be 672,700. And then I did that in my head because I knew that when we divided on both sides by 100, we wanted to come out with 6,727, just the same way as we did over here. Okay. Problem 16. Jeff answered 66 questions correctly on a test and received a score of 44%. How many questions were on the test? Okay, so again, think of this in terms of part and whole. That 66, is that part of the questions on the test, or is that all of the questions on the test? Okay, 66 is only the ones that he answered correctly. Okay, how many total questions are on the test is what we're being asked to find. So that's going to be our x. We know that the percentage is 44%. And again, you can set this up like this, 0.44x equals 66. Here, if we cross multiply, we get 66 times 100 equals 44x. And so then if we divide on both sides, we get 150. All right. And again, if you think about part and whole for this problem, right, this is obviously all of the votes. So this is the whole, and the part is the number of votes that the winner received. Let's see. 18. What is the commission rate if Raleigh earns a commission of $102.24? So this is the commission. And the sales were $568. Okay, so notice there's no percentage in this problem. That means that's what we're trying to find. We're trying to find the percent. Which is the is, which is the of. Remember, which is the part, which is the whole. This is the whole part. This is all the sales. A commission is going to be a piece of that the sales rep gets. Okay, so that means is 102.24, of is 568, and then that percentage will be the x. Okay? If you set it up this way, you would say 568 times x equals 102.24. All right, so here 568x is going to equal 102.24 times 100. And then we've got to divide on both sides by 568 here. 102.24 divided by 568. And that gives us 18%. Pretty high commission rate. All right, let's see here. Problem 20. A basketball player hit 16 out of 20 free throws in a game. What percentage of free throws did the player make? What percent did they miss? Well, this is actually very similar to problem 18, okay? Because they made 16 free throws. The total number of free throws was 20, so 16 is the is, 20 is the of. We're looking for the percentage, all right? Or we could say 20 times x would be 16. All right, so let's see, this will be 20x equals 16 times 100. Looks like 80%. Divide on both sides by 20. X equals 80%. If we did this, notice how we would get 0.8. X equals 0.80. And you can move your decimal point, or you can multiply by 100, but that's 80%. Okay? Because remember that in this method, that percent always shows up as a decimal, whereas here it shows up as the actual percentage number. So that's the percent made. That means the percent missed equals 20%. Right? You can do that numerically. 4 out of 20 would be 20%. You can also just do 100 minus 80 would give you 20% as well. Okay, let's see here. Where are we? Problem 22. A charitable organization raised $4,800 in a fundraiser. If this is 60% of their fundraising goal, what is that goal? Okay. And the percentage is 60%. So this is 60%. Notice the whole, the of, is always 100%. Okay, so that's another hint in this problem, is that in terms of deciding what's the part and what's the whole, okay, that goal is the whole. All right, and that is 100%. This is 60%. So if we set this up, we would want to say 4,800 over x equals 60 over 100. So then 60x is 4,800 times 100, and then we just have to divide. 480 into 3 divided by 60, 8,000. And that comes from dividing on both sides by 60. Now if we do this the other way, right, we would say 0.60 times x is 4,800, and then we would just divide on both sides by 0.60. So 4,800 divided by 0.60, again, gives us 8,000. And I'm doing these both ways in most cases here. You just need to choose one of these ways, and whichever way makes more sense to you is the way that I recommend that you go about doing these problems. Okay, 24. Flagstaff, Arizona received 120 inches of snow one year. This was 150% of the normal snowfall amount. What is the normal snowfall amount? So this problem's a little bit tricky because this percentage is over 100. Okay, so I've talked about this a couple times. If the percentage is over 100, then your part will actually be bigger than the whole. Okay, so this is the 150%. We want to know what's the regular snowfall, what's the 100%. Okay, so we're looking to find the of term in this problem. And if we were to do this the other way, we would have 1.5x equal to 120. Okay? Because this as a decimal, right? Move it over 2 places, and that would give us 1.5. All right, so let's see. If we solve this one, we've got 150x is 120 times 100, and then we do 12,000 divided by 150, and so x equals 80 inches of snow per year is the standard snowfall for Flagstaff, Arizona. Okay, we've got a couple more to look at. Problem 26. In an acid solution weighing 120 grams, there are 35 grams of acid. 35. To the nearest whole number, what is the percent of acid in the solution? Okay, so I wrote total. That word was not in the problem, but it seems pretty evident to me that this is the whole, this is the part. Okay, so we've got 35 grams out of 120 being pure acid, and the rest is whatever is in the solution, often water. Okay? If we were to set it up this way, it would say 120 times x is equal to 35. And so if we do 35 divided by 120, and this is one of those ones where the problem asks you to, or does it? Let's see. Oh yeah, to the nearest whole number. So to the nearest whole number, we've got 0.2916 repeating. So to the nearest whole number, that would be 29%. Over here, we do 120x equals 35 times 100. And so that just, like I said, that gives it to us already in percentage form, 29% approximately. All right, let's look at one more problem here. Problem 28, Ms. McShane received 2,860 votes in an election. This was about 58% of the votes cast. Approximately how many votes were cast? Okay, and I'll add in all, right? Because that's the total, that's the whole, that's what we're looking for. That's the of piece. So 2,860 is our is. We're looking for of. The percentage is 58, and so we just need to find x. In this one, it would be 0.58 times x equal to 2,860. All right, let's see here. So if we solve it this way, we divide on both sides by 0.58. 2,860 divided by 0.58 is approximately 4,931. Over here, 58x is 2,860 times 100. And so we would do 286,000 divided by 58. And again, it's approximately 4,931. Does this one say to round off? It says approximately how many votes were cast. So we can go with 4,931. Okay, so that's it for the percentage applications. Please do the odd problems on here. I've got an answer key with it. And then when you're done, again, if you have any questions, you can email me, you can call me, however that works. And we will, next week, we'll get the Zoom meeting once per week. We'll get that started as well. So until then,